So for my project, I did it based on the athletics events, especially with like medalists and non-medalists and all that good stuff. So here what I did was I have the two CSVs, which is going to be the athletic events CSV and the name of regions CSV, as you can see right here. So for the first slot right here, what I did was I first imported the libraries that I need for the project. The XGBoost and the LightGBM are the two advanced machine learning algorithms that we did not use in the class. Pandas and NumPy handle data processing. Scikit-learns gives me the tool splitting the data and evaluating the models, and I turn off the warnings so that the notebook is easier to read. So when you basically run this right here, it should print out setup complete, and the libraries are loaded successfully, which shows right here. So we basically have no issues in this first cell. So in the next cell that we have right here, I basically load in the two data sets. We have the athlete events and the NOC regions. So I merge them together using the NOC code so that every athlete includes their region or country. That gives us more meaningful features because the region turns out to play an important role when predicting the medal success, basically. So it plays a role in predicting the medal success. Now for the third slide that you can see right here, well, before we do that, I just want to show you that it shows us the shape after the merge, and then we have the NOC region and the region itself. Now for this next plot I have here, I basically did was I prepared the data for modeling. I filtered for Summer Olympics, converts the model column into a binary value. One basically means if the athlete won any medal, and if they did not receive a medal, it's going to be a 0. And what I did here was I kept only the basic numeric features like age, height, weight, and year. I also have one hot encode region so that the model can use it. And then I finally print out the shapes of X and Y to make sure that everything looks correct. As you can see right here, when I run it, I got the X shape to be this, and then the Y shape to be this, which means we did it right. Now for the next slot we have right here is the train test split, as you can see right over here. Now what it does is in the cell, I basically split in the data set into training and testing sets. 80% of the data is used for training and 20% is used for testing. I stratify the split so that the medal ratio stays consistent between both sets. So here we have the train size and the test size after we did this code right here. Now for the next one that we have right here is the XGBoost and the accuracy for XGBoost. So I trained the first model using the XGBoost. I specified the number of trees, depth, learning rate, and random speed. Then I fit the model, make predictions on the test set, and calculate the accuracy score. This tells how much often XGBoost correctly predicted medal outcomes. So you can see right here that the XGBoost accuracy is going to be at 85.1%, which is actually pretty good. And then I basically did the same thing, but it's using the LightGBM. It's similar, but LightGBM is faster and memory efficient. LightGBM uses NumPy arrays internally, so I pass the dot values to avoid features name issues. I again computed the accuracy so we can compare the two models. So as you can see right here, that the LightGBM accuracy is going to be that 85.2%. And then what I did was I compared the two right here. You can see the XGBoost accuracy and the LightGBM accuracy. So you could see here that the XGBoost performed slightly better compared to the LightGBM. Now for the reports, right? So I put it right here. The reason why is because the accuracy doesn't always tells us the full story, or you could say the full information. So I basically generated a classification report. These include precision, recall, and F1 score for both the medalists and non-medalists. Medalists are a minority of the class, so this helps us to understand how much well each model detects them. So you can see right here, you can see the data for the precision, the recall, the F1 score, and the support. And then you have the accuracy, the macro average, and the weight average. just like how I explained before. Now for the next one, what we have right here is the confusion matrices. So I print the confusion matrices for both models. These show the true positives, false negatives, the true negatives, and the false negatives. Since predicting medalists is harder, looking at the false negatives is especially important. So you can see right here, I have the confusion matrices for both the XGBoost and the LightGBM right here. Now for the last and the final thing I want to show is the two visualizations. So you can see right here, for the first one, what it basically shows is for the XGBoost. So this shows which features are contributed most to the predictions, and region and year are often high on the list, showing a geopolitical and historical events. So you can see right here that the majority is from year, height, weight, and age, but majority is from the year. And now you have the second one right here, which is going to be the medal distribution plot. That's going to confirm the data set is imbalanced with many more non-medalists than medalists. And then finally, to conclude like all the data that we did, basically the results show that the XGBoost and the LightGBM can successfully model the Olympic medal outcomes using a small set of data features. Between the two, XGBoost achieved a slightly higher accuracy, delivered more interpretable feature, important results. The models highlighted regions and years as meaningful predictors, reflecting long-term geographic trends in Olympic success. While physical attributes such as the height and the weight also played a role, overall, the gradient boosting approaches proved to be effective tools for identifying performance patterns in the Olympic dataset, demonstrating how machine learning can extract meaningful insights from over a century of athlete history. So that is pretty much what I did for my project, and hope you all have a good day.